Good morning, ladies and gentlemen. This is the last video of 2017-2018 school year. So, please follow through if you need it to help you on your exam review, okay? This is what I'm working through, the exam review. So, number 1. Here's the equation. Zn plus O2 gives you 2ZnO. How many grams of zinc oxide can be produced from 100 grams of each zinc and oxygen? So it says each, so you have two things here. So you can start with two, you're going to make two heads. 100 grams of zinc and then 100 grams of oxygen, O2. Alright, and so what are we looking for? We are looking for, let's read the question, how many grams of zinc oxide? So there it is, ZnO2. So we want to find grams of ZnO on both of them, and so we have to set two heads to find both of them, and the one that gives you the least is your limiting reactant, or the one that limits, and that would give you the answer, the one that's the least of the two. Okay, that's the maximum that you can make. So let's go through, fill this in. Mole of zinc, mole of zinc, the first one, mole of the second one, ZnO, mole of the first one, mole of the second one. Okay, and then we copy the units down here, whatever units here, bring it down, grams of zinc, copy the unit here, mole of zinc down to the next one, and then mole of ZnO down here. The pattern, we've done it so many times, keep bringing it down, like cross, keep bringing it down to the next one. And grams of O2 here, mole of O2 there, mole of ZnO there, okay? Okay, now filling in the numbers, it's fairly easy. Mole and gram, always 1 mole. Where do I get the grams? Periodic table. Zinc is, periodic table, 65 grams. It's the mass right below the symbol. Mole and mole, look at the equation. 2Zn, 2ZnO, 2 to 2. ZnO, mole and gram, 1 mole. Zn is 65, O is 16, that's 81 total. You add them up together. So that's 81 grams. Okay. Anytime you see grams, you have to use the periodic table. Okay, the bottom one, 1 mole of oxygen is 32 grams. Mole over mole, 2ZnO from 1 and 1O2. Look at the equation, mole and mole. The balance equation, the coefficient in front of oxygen is, there's no number, so it's 1. And then ZnO here is same thing, 81, same on top. Okay. Multiply all the top, divide the bottom of the top one. There you go. 124.6. 124.6 grams of ZnO. That's the top one. Is that the answer? We don't know yet. If it's the lesser of the two, then it is. If it's greater than the bottom one, then it's not. So 100 times 2 times 81 divided by, 100 times 2 times 81 divided by 32. This one's 506 grams. So the top one is the answer because it produced less, and that's the maximum that you can make. Okay? The bottom is 506 grams of ZnO. So that's number 1. Number 2. For the reaction, how many moles of potassium chloride are produced from 119 grams of potassium bromide? Potassium bromide. Here. 119 grams of KBr. Okay? And so it's grams, mole, grams, right? Remember our order of things? But what is it asking for? It says, how many moles of potassium chloride, KCl? So we just need to go to KCl here. We don't need to go to the last grams. So it's just grams, mole. So this mole is KBr, the first one. The last one's mole, KCl. Okay. Grams go down here, KBr, because we start with that. And then mole of KBr goes down here, KBr. Okay. So moles and grams, 1 mole. Where do I get the grams? From periodic table. K is 39, Br is 80. 39 plus 80, that gives you 119. Oh, perfect. Look at that. And then KCl and KBr right here. Look at the equation. Mole and mole. 2 to 2. So the answer is, they cancel out, that cancel out, and you multiply the top divided by the bottom, you get 1 mole of KCl. That's nice and sweet. Yes. Know the steps, know how to do these. Okay? Number 3. A sample of neon gas, number 3, occupies 4.5 liters. So there's a volume, 4.5 liters. There's a temperature 30 degrees Celsius. There's a pressure, 2.5 atm. What volume will it occupy? Oh, there's a new pressure, so there's a pressure 2. So these are all 1s. Pressure 2 is 1,000 torr. And then T2 is 300 degrees Celsius. And V2 is what we're looking for. So, this seems like a V1, P1, T1 equals B2, P2, and T2 problem. Okay? That's what kind of problem it is. So, what we do is, we make sure that the units are the same. Temperature needs to be in Kelvin, so add 273. That's 303 Kelvin. Add 273, that'll be 573, that's huge. And then torr and ATM, look at these. They're not the same units. So I'm going to change them both to ATM by dividing by 760 here. So 1000, because 760 torr is 1 ATM. Divided by 760. And I get 1.31516. Okay? ATM. So I plug into that equation, V1, 4.5, P1, 2.5, equals T1 over T1, 303, equals V2, T2, P2, sorry, 1.316, over T2, 573. And that's that. Cross multiply this way, and then divide by everything else. Okay? So 4.5 times 2.5 times 573 divided by 303 divided by 1.316, and I get 16.1. So I get 16.1 there. So my V2 is 16.17 liters. The first one's liter, right? Yeah, liter. So V2 will be liters as well. Okay. That is number 3. Let's go to number 4. How many moles of argon? Number 4. How many moles? So then, therefore, you're looking for an N. So with gas laws, it's going to be PV equals nRT. And remember, R is a constant. It's 0.0821. P needs to be in ATM. V needs to be in liters. Temperature needs to be in Kelvin. Okay. And so 75 milliliter. V equals 75 milliliter. Divide by 1,000 to get to liters. So 0.075. T is 33 degrees Celsius, which you need to add 273. That's 306 Kelvin. And then pressure, that's nice, 1.07 atm. Okay? So there it is. VTP. So we plug it in. P, 1.07. V, which is 0.075, equals N. R is 0.0821 times 306. Alright. So we need to divide by these two suckers over here. 0.0821 divided by 306 to get that answer there. 1.07 times 0.075 divided by 0.0821 divided by 306. And I get, oh my, 0.00319 moles. Tiny, tiny amount of gas. Tiny amount of gas. 101, that tiny little number, okay? 100,139. 319 moles. Number 5. 5. A dentist. Laughing gas. 5 liters as a volume. And then there's a pressure. pressure of 20 atm. There's a temperature, 25 degrees Celsius. And what mass is contained in it? So in order to find mass, we got to find mole first. Okay. Another PV equals nRT. Pressure 5V. I'm going to put V first. Go ahead. Pressure is 20 equals N, which is something. R is 0.0821 times T, which is, oh, we need to add 273 there, 298. Solve for N again. Divide both sides by 0.0821 and 298. Okay, so 20 times 5, right? 20 ATM, that's an ATM, times 5 liters, divided by 0.0821 divided by 298. Voila. 4.087 moles of this thing, which is N2O. Okay? So with that mole, you need to change it to grams. It's asking for gram. 0.087 times mole of N2O. 1 mole of N2O. N2 is 14, 14. 14, 14, and then 16. 44. 44 grams of N2O. And multiply that, you'll get your answer. Should be 179.8 grams of N2O. How cool is that? Okay. Number 6. Number 6. A sample of gas collected. It's a gas law problem here. Number 6. 750 mmHg. That's a pressure. And there is 250 milliliter. That's a volume. At constant temperature, so there's no temperature. Pressure does exert at V2 is 300 milliliter. And PU2 is what we're looking for. Okay. Again, we go back to that V1, V1, V2, T1 equals V2, P2, and T2. And the fact that temperature does not change, it cancels out. So we have V1 times P1 equals V2 times P2. So V1, 750 times 250 equals 300 times X. Okay, so divide both sides by 300. 750 times 250, 625 milliliter. Oh, not milliliter, mmHg. The same unit for your pressure. Okay. So you might ask me, does it matter if this is millimeter of Hg, or does it matter? Does it have to be in liters? No, not for P1, V1, P2, V2. Okay, as long as they're the same. Look, ml, ml, they're the same. So this is mmHg. That has to be an mmHg. As long as they're the same on both sides, they're fine. Okay. PV equals nRT. You have to have them specific. All right. I'll stop here for now, and I'll continue in the next video on the next couple questions.